Good afternoon, children. Today we'll discuss about the cyclic structure of glucose. Previously we have discussed about the open chain structure of glucose in this way. C1, 2, 3, 4, 5, 6 is your double bond oxygen, single bond hydrogen. First, second OH, third OH here, H, OH, 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 H, 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 H. Most of the properties of glucose is being explained by the open structure of glucose, but few chemical reactions and effects could not be explained by the open structure of glucose, and they are: number one, despite having the CHO group, aldehyde group, glucose does not give 2,4-DNP test, does not give 2,4-DNP CIFS test, and hydrogen formation of hydrogen sulfide on reacting with sodium bisulfite also cannot give. So although it is having CHO group, these tests cannot be given by glucose. Then coming to the second one is the pentaacetate. The pentaacetate of glucose does not react with hydroxylamine, indicating the absence of free CHO group. The third one is glucose is found to exist in two different crystalline forms named as alpha and beta. The alpha form of glucose, whose melting point is 419 Kelvin, is obtained by crystallization from concentrated solution of glucose at 303 Kelvin, that is a 303 Kelvin. While the beta form, whose melting point is 423 Kelvin, is obtained by crystallization from hot and saturated aqueous solution of glucose at 371 Kelvin. This behavior could not be explained by the open chain structure of glucose. It was found that the OH at carbon number 5, 1, 2, 3, 4, 5, the OH at carbon number 5 linked to CHO group and form a ring. This explains the absence of CHO group and also existence of glucose in two different forms, as it will be explained on the board. What happens? Let me write it. So alpha and beta form can be written if we are putting this structure in the middle. 1, 2, 3, 4, 5, 6. Double bond oxygen, hydrogen, OH, H, OH, H, OH, H, OH, OH, H, H and H. This is your carbon number 1, carbon number 2, 3, 4, 5, 6. So the OH group at carbon number 5 is linked to aldehyde group. Then the structure will be one, two, or let me write Fisher 1. Where is the कार्बन, ठीक है. So carbon number 5, the OH group present in the carbon number 5 is linked to CHO group, and this cyclic chain or structure is being obtained. The other side is carbon, the only difference between these two forms is to this carbon, the first carbon, the OH group is inside the ring to the right hand side of the carbon, whereas in this particular structure the OH group is on the left hand side of this carbon. So this one is known as alpha D plus glucose, and this one is named as beta D plus glucose. The two cyclic hemiacetal forms of glucose differ only in the configuration of the hydroxyl group at carbon number 1 called anomeric carbon, that is the aldehyde carbon before cyclization. Look at that. One is to the right hand side in alpha, whereas in beta form it is here to the left hand side. Which isomers, that is alpha form and beta form, and such isomers alpha and beta forms are called anomers. The six-membered cyclic structure of glucose is called pyranose structure, that is alpha or beta form, in analogy to pyran. This structure you can see on the board. The alpha and beta form cyclic structures, we can go in this way. Simultaneously we will go so that you can easily differentiate them. First, second, third, fourth, fifth, and here will be CH2 OH sixth. First, second, third, fourth, fifth this carbon, and sixth one is your CH2OH. Just compare it. Compare the structure to the first carbon. In case of alpha, H is your top and OH is your down. In case of beta, OH is at the top and H is your bottom. Whereas the other structures, carbon number, so let us write about 1, 2, 3, it will be better. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. The difference of the hydrogen atom and OH group are differ only at carbon number 1, and rest you see at carbon number 2 it is your H, OH, here also will be H, OH. To the third carbon it is just reversed. So OH, H, OH, H. Next is your OH will be down as in second carbon. OH, H, OH, H, and here is your थोड़ा छोटा करके hydrogen atom, hydrogen atom. Rest are same, only the difference is at carbon number configuration at carbon number 1. This is called alpha D plus glucopyranose, alpha D plus glucopyranose. It is similar to that of pyran structure, and this one will be beta D plus glucopyranose. So in drawing this structure, these structures usually being asked in the board exam. So you can compare these two and then draw, then only you can differentiate them easily. I hope the cyclic structure of glucose is clear to all of you. Thank you.